What if the laws of physics suddenly changed? Imagine a world where the very rules that govern reality are rewritten overnight. What if gravity vanished, time reversed, the speed of light fluctuated, or the relentless march of entropy suddenly turned back on itself? These aren't just abstract thought experiments, they're doorways into understanding how fragile, how exquisitely balanced our universe truly is. Join us as we explore the mind-bending consequences of rewriting the universe's most fundamental laws. Gravity, the invisible hand that keeps our feet on the ground, the planets in orbit, and the stars burning bright. It's so familiar, so constant, that we rarely stop to consider its profound importance. But what if, in an instant, gravity simply switched off? The immediate consequences would be nothing short of catastrophic. Unanchored from the Earth, everything not bolted down would begin to float away. People, cars, trees, even entire buildings would gently rise into the atmosphere. The atmosphere itself, no longer held in place, would begin to dissipate into space, leaving the Earth exposed to the harsh vacuum. And the oceans, freed from gravity's pull, they would break free from their basins, forming colossal spiraling blobs of water drifting aimlessly. The moon, no longer bound to Earth, would drift away into the solar system, causing unimaginable tidal waves and tsunamis before it departed. Earth itself, now untethered from the sun's gravity, would break free from its orbit, becoming a rogue planet, hurtling through the cold, dark void of interstellar space. As Earth drifts further from the sun, temperatures would plummet, the oceans would freeze, and the atmosphere would thin to nothing. Soon, our once vibrant planet would become an uninhabitable, ice-covered rock, a silent testament to the force we took for granted. Now, let's consider an even more unsettling possibility. What if time itself began to run backward? At first, the idea might seem appealing, a chance to undo mistakes, to relive cherished moments. But the reality of reverse time would be far more disturbing. Events would unfold in reverse order. A shattered vase would spontaneously reassemble itself. Food would undigest, returning to its original form on your plate. Conversations would become garbled streams of reversed speech, as words flowed back into mouths, sentences unforming themselves. Even more unsettling, people would begin to unlive, growing younger, not older. Eventually, returning to the womb, their lives playing out in reverse. But what about our memories? Our consciousness? Memory relies on the forward flow of time, on the accumulation of experiences in a linear sequence. If time reversed, we would lose our future memories, the experiences yet to come. We might even lose consciousness altogether, becoming mere observers of our own unlives. The disruption wouldn't be limited to our minds. Our very biology would be thrown into chaos. Metabolism, the engine of life, would reverse, potentially making life unsustainable. The universe itself relies on the relentless increase of entropy, the tendency toward disorder. If time reversed, this fundamental principle would be violated. Stars might unburn, drawing energy back from the cosmos. Black holes might regurgitate the matter they have consumed over eons. Time is the framework upon which all of existence is built. To reverse it is to unravel the very fabric of reality. The speed of light, a cosmic constant, the ultimate speed limit of the universe. It's the bedrock of our understanding of space and time. But what if this constant were to change? What if light suddenly slowed down, or even more bizarrely, sped up? If the speed of light were to decrease, the consequences would be immediate and far-reaching. Our communication systems would grind to a halt. Fiber optic cables, lasers, GPS satellites all rely on the constant speed of light to function. The internet would collapse, data centers would lag, and real-time navigation would become impossible. But the deeper implications are even more profound. The geometry of the universe itself would shift. The balance between energy and mass, as described by Einstein's famous equation, E mc2, would change. Stars might shine less brightly, their thermonuclear reactions stalling as the speed of light decreased. Now imagine the opposite. The speed of light suddenly increases. Information could travel faster than causality. Paradoxes would emerge. Effects could precede causes. An object could seemingly appear in two places at once. Space-time itself might begin to unravel. The very fabric of reality could rip apart, dissolving the boundary between past, present, and future. The second law of thermodynamics states that entropy, a measure of disorder, always increases over time. It's the reason why ice melts, why buildings crumble, and why the universe is slowly winding down. But what if this fundamental law were to be broken? What if, instead of increasing, entropy began to decrease? In our daily lives, the effects would be surreal. Hot coffee would spontaneously heat up. Air would settle into perfect stillness. Food would unspoil, returning to its pristine state. Cracked glass would reassemble itself, piece by piece. Even more disturbingly, dead things might come back to life, their bodies regenerating as entropy reversed its course. On a cosmic scale, the effects would be even more dramatic. Stars that had died might reignite, drawing energy from the surrounding void. Galaxies might reform, their stars coalescing into perfect spirals. The universe itself might begin to reverse its course, moving toward a state of perfect order. But there would be a dark side to this apparent perfection. Life itself depends on energy gradients, on the flow of energy from one place to another. If entropy decreased, these gradients would disappear. No reactions would occur. Everything would settle into a state of stasis. The pursuit of perfect order would lead to absolute stillness, to a universe devoid of life and change. These scenarios may seem like pure science fiction, but they raise profound questions about the nature of reality. Is it possible that the laws of physics could change? Some cosmological models suggest that different universes might exist with different physical laws. Perhaps our universe is just one of many, each governed by its own unique set of rules. Quantum mechanics suggests that extreme fluctuations in the quantum vacuum could, in theory, create alternate universes with different physical constants. Another possibility is vacuum decay. The universe might exist in a false vacuum state, a metastable condition that could at any moment decay into a more stable state with different physical laws. And then there's the simulation hypothesis, the idea that our universe is not real, but a computer simulation created by an advanced civilization. In that case, the laws of physics could be altered at will by the programmers. These are all highly speculative ideas, but they force us to confront a fundamental question. How stable is the reality we trust? So, what have we learned from these thought experiments? What happens if the laws of physics suddenly changed? No gravity, Earth drifts, oceans rise, life ends. Time reversed, memories fail, entropy collapses, biology breaks, light speed altered, logic dies, causality vanishes, thermodynamics reversed, perfection becomes stagnation. The universe is a delicate dance of forces and constants, each exquisitely tuned to allow for the existence of life. Which law would you dare to change? Think carefully, because even the smallest alteration could have unimaginable consequences. Like this video, subscribe for more mind-bending explorations of the cosmos, and remember, reality is only stable until it's not.